Please start the live streaming.
Yeah, we are live now. Please go ahead.
Sir, we can start. It is live now.
Okay. So good evening to all of you. I hope like my screen is visible to everyone. Today, I'm just going to focus on one very important aspect, which is very much missing in modern day data science processes. That is data-driven decision making. So today's talk is going to be focusing mainly on not the regular ML AI aspect of it, or like the data science which you feel like the machine learning models and artificial intelligence models and deep neural network models. These are not something which is going to be the core of today's talk. Our talk is going to be what is the ROI driven, data driven decision making. So today what happens is in modern day, we see data science is a high buzzword, one of the highest paying job or highest paying domain, and everyone want to become a data scientist or a data analyst or a data practitioner. But what happens is we all start into an area which is equivalent to hacking, you can say. Whenever I say data science, I always correlate with the cybersecurity, because in cybersecurity, there is no straightforward way or this is the way you need to follow in order to solve a problem. Likewise, in data science also, if you take a course or if you finish a course, that will not be sufficient for you to become a data-driven decision maker. So how to become a data-driven decision maker is what is our core theme today. Now, I hope my screen is visible to everyone.
Yes, yes.
Okay. So during this session, I'll be giving in the middle, I'll be just looking for a small quiz, which I'll be giving. You can just post answers on chat box, or even you can unmute and answer that. Just a quick one. So let's get started. Data will talk to you if you're willing to listen. This is something which we have in our office itself, which is very much motivating quote for our day-to-day operation. You know, whenever we talk about data, the data which we are going to analyze are not the data which is smaller in size or maybe very enjoyable. Yes, for a small data set, you will open up a spreadsheet and start exploring, and you'll come up with interesting insights. But when you open up a data which is huge in size, which most of the softwares take time to load itself, within few days, you will get into a state of mind where it will be more vague and it will be very much non-interesting. So whenever such situation comes, this quote used to really refresh our brains. That is, data will talk to you if you're willing to listen. Let's see how data talks in the end of the session. By end of the session, you will understand how to really use data in order to bring actionable insights. So when I'm telling about data, that is the rise of AI. Today, we say the generative AI, the chat GPT, all these modern things which we are talking about, we call it as the rise of AI. But whenever we say the rise of AI, something which reminds me is the rise of literacy. Few hundred years ago, they both have something uniquely similarity. That is, few years ago, I mean like hundreds of years ago, literacy was not everyone's cup of tea. Everyone doesn't need to be illiterate. Like most of the time, we used to do the farming, we used to gaze the sheeps, etc. and all. Only the people who really need literacy was the high priests, monks, who used to read the spiritual books, holy books. And for that particular purpose, they need literacy. And we used to go to them. They used to read it for us in the temple or mosque or the church. But today, if you really see, everyone are at least able to read and write. So from the beginning where everyone does not want literacy. Today, we have reached to a state where literacy is mandatory for everyone. Everyone needs to read and write. Likewise, today AI is in a state of point where it is in the hands of high priest monks who are called the AI engineers, who can read and write code. Now, in upcoming time, majority of our economy is going to be driven. Even now, it's been driven using AI, knowingly or unknowingly, irrespective of different verticals. You can see AI is being applied, whether it is healthcare, BFSI, telecom, whether supply chain logistics, education. Likewise, AI is applied everywhere. And today, whether you like it or you don't like it, the mobile phone which you're handling itself is having a lot of AI components attached to it, which is simplifying you the process of decision making in your day-to-day life. So how to make the modern generation AI driven and how to use AI for right purposes. That's what is all about, the rise of AI. Now, when we really see the AI's long tail customization problems, you can see most of the today's AI problems which have high values are belonging to this area, that is the ads, the web searches, etc. Now, whenever we see ads, Facebook, Google, Twitter, LinkedIn, all these people use AI to do their ads monetization business higher. Next is web search, whether it's Netflix, Amazon, everyone use AI for doing the custom recommendations or contextual recommendations. But there are some areas where AI shows small value, but it is a huge area where AI can be applied. That is nothing but sales forecasting, fraud detection, inventory management. Ads and web searches may be a problem of big corporates, but these are for everyone who runs a business. So we should understand AI is going to be used in different areas, but at this moment, only very few people know how to build AI systems and how to gain insight after it and how to convert it into an ROI-based business. So misconceptions about data science. Whenever we say misconception means like in modern day, when you see the AI is being very much taken in a wrong way. How it is, I'll tell you. When you see this diagram, you can see there are lots of boxes, but there is one particular small box in the middle, which is darker in color called ML code. Today, majority of data science practice, like enthusiasts, some of the students who wanted to become a data scientist, all focus on this black box, which is in the middle called ML code. They say, okay, if I go and learn a Python course, if I go and learn a machine learning course, if I go and learn an algorithm course, I'll become a data scientist? Absolutely no. It's not the reality. But that's the first phase, first step. When you really see AI, it is much bigger than what you think, like starting from configuration, data collection, data verification, machine resource management, analysis tools, feature extraction, process management, serving infrastructure monitoring. It's a very big space where our focuses are only on prediction. And this really has a very big side effect. How? I will tell you. Now, for people, AI is like a magic wand. Everyone want to learn artificial intelligence. They want to use AI systems. So they feel AI means it's a magic wand. It will give you a prediction which can be helpful for you to take a decision. And for businesses, AI, they think it's a money printing machine. But to be frank, what AI really is, a beautiful orchestration of multiple players, not a single person with data and analysis. Whether the data provider, the infrastructure provider, whether the business owner, like that, everyone should properly orchestrate. That is what is AI is all about. It's not a single person game. If any one particular person doesn't play very well, the total inferences which you draw out of it is going to be wrong. Now, building AI is easy, but orchestrating AI is very challenging. Why? Let's see. Today, the ecosystem of AI is evolving in such a way that today, if I go and say that I want to become an AI engineer, minimum I should know 10 to 20 tools from this list. And it's not easy for a person who comes from a non-technical background to learn all these things. Very rarely, few achieve that, where others won't. The reason is most of today's AI systems are code-driven. If you really wanted to build an AI model, you need an AI engineer. And if you really wanted to deploy it, you need an MLOps engineer. And if you really wanted to build any simple application, minimum, you should be able to read and write code. But what is happening is AI engineers are good in building AI models and giving it to you, but AI is not really helpful for them. AI and data science is very much helpful for the person who's a decision maker. Consider a manager, consider as a vice president, consider the CEO of a company. They are the one who can really take actionable decision from the AI inferences, whatever you gather, or the data inferences, whatever you have been creating. In modern day, what is happening is majority of organization in India itself, this is a real fact, which can really be useful for everyone. That is, all the companies wanted to take that first approach of taking the AI into their regular process. Everyone want their company to be AI driven. For that, what they do, very simple. They already have an existing task force or the workforce. And what they do is they go to the market and buy all the AI products like Tableau, Power BI, IBM Cognito, like the different types of tools, SAP, SAP, everything they buy and bring it. Here, I just wanted to put a simple metaphor. It is exactly like a father who likes his son very much, and he is going and buying a guitar for the son and giving it to him and say, hey, you just learn guitar and become a great artist one day. When you see this scenario, 90% of people won't really learn guitar. Out of the 10% of people will be a master of it. They will become a pro in playing guitar because of their interest, and they start exploring more. But the 90% of people, what they do, within 3 months, the guitar will lie in the corner of the home. Now, the father will ask, what is the ROI? What is the return on investment? I've invested for you on the guitar, but the guitar is lying down in the corner of the room. What is the reason? It's not father's mistake, or it's not the child's mistake. The mistake is, if the father also provided the right training for him, this 90% of could have been reduced to 50 or 30%. Majority of people could have learned guitar. The same is happening in industry today. The industry is like father. The organizations are like father. They invest huge money on AI tools and give it to their employee, who are their children. And these employees, they start using it. Within few months, they get totally diverted and they become stale. Most of the tools which are bought are becoming useless. It's not because of tool or the organization or the employee. It's all about no right training has been given. And most of the time, what happens is these tools without training will always give you, most of the time, it will give you wrong inferences. And that wrong inferences, you will not be able to take any decision. In our real world, in real time itself, I have worked with a couple of bigger organizations where most of this data science tools have been implemented. They start collecting data, they keep it, but till now, they are not able to trust the data which has been collected because of only one reason, that there is no clarity in what they collected. Just because they want to collect every data, they collected it. End of the day, whenever they wanted to come up with an inference, they're not able to believe that this inference is something which I can take action out of it. Second bigger problem which in modern day everyone faces is, a CEO has invested huge amount of money on all these AI tools in order to get an actionable insight. But our majority of CEOs, I think majority of students who are from the corporate, you do agree with it. All the time, what happens is, you have put investment on these tools. These tools get a lot of reports, and one fine day, every day in front of your table, a huge bunch of reports are there. And every time the decision maker has to go through all these reports, and he's telling how to take an inference. What kind of inference can I gather from that? This is happening because of a huge dump of reports will not give you actionable insight. Hello? Yeah. Huge amount of reports always mislead you. So how to take actionable insight? A good insight does not need to be 10, 20, 30 pages. It can be 2 pages or even a single page. You can shrink it down. How that comes is with the domain knowledge. So as the ecosystem is growing on, the need for learning AI and applying AI for a non-technical person is becoming very, very important. So this talk is going to be for them. Now, when you really see, for getting a very small prediction, that is, it can be any prediction, you need a big programming tools, different data engineering tools, which collaborated and orchestrated to get one single prediction, like tomorrow rain will come or not, tomorrow what will be the sales, what is the chance of a person getting cancer or not, like that. A very simple inference, it requires a huge ecosystem behind it. So when we really see AI, offline training, data normalization, data pre-processing, feature processing, data schema, model processing, then performance degrade, distribution shift, data drift, like that, altogether, it is inviting a scary AI ecosystem. Because everyone think that writing a simple Python code and running a scikit-learn model can make you or model perfectly successful. That's absolutely wrong. It is a first stage. When you really deploy an AI model in production, an AI model has a lot of things you need to consider, right from the deployments. The next thing is a retraining cycles. Third thing is monitoring data drift, concept drift, like that. Lot of data leakage, data lineage, like that. Lot of things are there under that. Slowly your model will start degrading. So managing all these things is going to be a masculine task. Without a proper idea, it is going to invite a big scary AI ecosystem. So now everyone will be coming into this particular point, that how AI ML can benefit me. How can I adopt AI? Is there a way to convert unpredictable failures into predictable diagnostics? Whether it is failure of a huge physical asset or a human vital, or it can be anything. Is there a way where we can be proactive rather reactive? Now, I just wanted to put a very simple question to all of you. If you have chat box or anywhere, if you have anyone wanted to answer, you can answer. I'm giving a small data, which is like having date, country, state, district, total new cases, total recovered, total death. Does anyone understood what this data set is all about? You can post it on the chat box. Very good. Ankita said COVID. Very nice. I'm very happy. Okay, tell me, from this data, what are the different types of questions we can ask? Some critical data-centric questions which we can ask from this data. And everyone, one question. It can be any question. There is nothing like a good question, bad question. Can anyone ask, okay, the rate of spread, new cases trend, which country has the highest rate, which state has the most affected? Very good, very nice. Percentage of higher, total number of death percentage, district wise, okay, total death, rate of recovery. Very good. I'm very happy to see that the questions are coming. Now, if I keep this set of data and I'm asking everyone to, there is a background noise is coming. Let me mute everyone, which is, I'll mute all. Okay. So when I'm asking all these different types of questions, you can see there are different types of questions are coming, which can be primary questions and secondary questions. Primary questions is only from the given set of data, what are the different types of questions you can ask. Secondary question is, if I'm having one or two different columns extra, what are the different other types of questions which we can ask? From this, I can understand more than 10 to 20 questions has been posted in the chat box. Now, if I have shown you this data directly with full actual data inside this, most of people will be asking some 2-3 questions. I wanted to know, can I ask any interesting question which is not very much descriptive in nature, where I can get some interesting insight of it? Is there any interesting question from this data points which we can ask so that will really add value? These all the questions which you have asked are generic questions. Anyone? Forecast a trend of future. Okay, predicting. I'm asking, can we take 2 or 3 columns, and from that, can I create another column and come up with a new interesting question? Which district requires curfew to be curved? The spread. Okay. And I'm also having, there is a field called date. Okay, district wise difference in recovery versus death. Okay, let me put you in a simple way. Does festivals have any impact on new cases, on any country or any state or any district? Is it a good question? Right? You have, and which type of, does the seasons or the climatic factor has any impact on rise on number of cases or not? Right? Now you can see a lot of people. Is it an interesting question? Most of the time, we are stuck with the descriptive questions, not going to the next step. The next step is all about which question is really actionable. The first 20-30 questions which was posted are generic, right? But when you really ask the questions from slightly a different point, this is where the domain knowledge comes into the picture. When you start opening up your mind to ask the right question, your data will confess. In the first slide, I said the data will talk to you if you are willing to listen. Why I said this? If you ask the right question, the data will start confessing. And that majority of people are missing. It's not about they are really missing it, because they are not being given this orientation that there is a way to ask question to the data. Now tell me, if I'm taking this entire batch, I'm splitting it into 10% per batch, and I'm giving the same data without any data inside that, only the column names, and I'm asking that come up with most interesting question. Every team will come with 10, 20, 30 interesting questions. And those questions, if you start filtering it out, you will be able to come up with very interesting, actionable insight, true or false. Right? That is what data-driven decision making. It's all about like, how can I ask the right question? Most of the time we are very much, for example, I can see most of newcomers or most of new joinees in our company, when I ask like the question, okay, like what really is needed to have a good data-driven decision making questions. Most of the time say, I need a very big data. I need big data. Big data means I need a humongous amount of data. This is the question. But I say, you don't need big data. You need quality data. It can be even small data. Most of the time, the small data can really help you to uncover the story better than the large chunk of data, which is having a lot of redundancies and duplications and issues. So first key takeaway for this particular talk is learn to ask the right question, because the core of analytics lies in the ability to ask the right question. Now, once you form that list of questions, now if I give a data to you, you know exactly what are the things you need to explore. Most of the time, what happened? We take the data, we directly open it in a spreadsheet or any similar tools and start looking into the data to analyze it, which you will not get anything. Most of the time, you will think, okay, already data is having everything. What I'm going to find it from that? That is because of you don't know exactly where to start. But before starting any data analysis process, start creating list of questions, potential questions which you can ask. Let it be primary, no issue. First, you take the list of primary questions. solve that particular questions using any tool of your choice. And next, start asking interesting question where you can combine multiple features and some of the facts which are out of box, which will give you more actionable insights. So I hope everyone is clear with it, right? Ability to ask the right question is the core of analytics. Now, let me take you to a very interesting point, okay? So consider that there are 4 pillars of analytics, which you could have learned, but I just wanted to reframe because I want to make that foundation pretty much strong so that any problem in future, you will be able to focus it in the same way. So when you really see the 4 core pillar of analytics, that is, you can see in this condition, I'm taking an example of a healthcare, okay? In healthcare, suddenly you are getting sickness, you're going to a doctor. When you go to a doctor, you're going for a consultation. The first thing what doctor does is, does the doctor prescribe a medicine? No, she'll not prescribe a medicine blind. First thing what she does, she'll ask your name, your age, where you're coming from, since when you're having this issue, and what have you been given medication previously? Are you under any medication? Is there any previous test report? Like that, all the information she will start collecting about you, all the information about your past. That phase we call it as descriptive phase, getting information about your past. Now after that, okay, the doctor thinks, okay, let's do one thing. Let's see that what is in real time your situation today, what is happening to you. So she'll write list of tests to be conducted in real time. You will go to the nearby lab, conduct this test and take the results and come here. Here, the data has been collected about your present, which we call it as diagnostic phase. Now, based out on this past and present, the doctor predicts the future. She's thinking, okay, last month your BP was this level, last week test report, it is like this, today it is showing a significant high. That means there is a chance that tomorrow you will become very sick and your BP is going to shoot up. The doctor is able to predict that only because of knowing the past and present data. Without that, a doctor cannot predict anything. So you should understand, any prediction works based out on understanding about historical and present data. Now, most of the data science aspirants, they think that predicting something is the final thing. But I would say it's not final, it's incomplete. If you think predicting something is final, that's an incomplete phase. That's not the completion of analytical process. When it becomes complete is, a doctor predicting what will happen to you tomorrow will not solve your problem, but it's a clue to solve your problem. When your problem gets solved is only when the 3 level of analysis like description, diagnostic and predictive, these 3 phases are taken to take an action. So most of the time what you can see, a doctor take a prescription pad and say that take this medicine. When you take this medicine only, your illness is getting cured. Doctor predicting what will happen to you is only helpful in writing the prescription, not curing you. So this action phase is called prescriptive phase. Okay, most of the time this prescriptive phase is domain centric. That is why in data science, if anyone say I'm a data scientist, in generic you cannot be a data scientist. Right? You have to be having one domain knowledge, whether BFSI, healthcare, or telecom, whether it is supply chain and logistics like that. You have to have one domain knowledge strongly. Then only you can write prescription. In modern days, this first 3 phases are 80 to 90% automatable. But the only area which is not automatable is prescriptive phase. This is where your domain knowledge plays a pivotal role. Now let's understand one simple thing. You all could have learned about the Titanic, right? Titanic is one of the cliche data set which is used in machine learning to predict whether the Titanic passengers survived or not. Let's take the same example here. Here you are having a data set which is having Jack, Rose, everyone are there just for the reference purposes. And there is one particular column called whether they survived or not survived. Jack didn't survive, Rose survived. And there are some people who didn't have the survival status. We don't know whether they survived or they perished. Now, when the statistics was evolving, people try to use statistical models to predict the state of these missing passengers. That means what is their current state. They try to predict. They got 70% accuracy. Now 70% accuracy during those times was not too bad, but it is not too great as well. Now in any prediction problem, we can increase accuracy by either two ways. Either you should have more number of observation, or you should have more detailed information about each observation. That means either you should have more number of columns, or you should have more number of rows. Now in this condition, more number of rows is impossible, because if 350 or 2000 passengers have traveled in Titanic, I cannot take another ship's passenger list and append to it and say that I'll build a prediction model. That's not the relevant. So number of observation is not possible. But can I get more detailed information about each patient? Yes. That's what we call it as feature engineering, right? So when they added one small feature, that is one extra column to inside this data using the existing column, with the logic that if gender is female and age is between 18 to 25, chances of having kid is 1. If gender is female and age is between 25 to 35, chances of having kid is 2. If gender is female and age is between 35 to 45 plus, chances of having kid is 3 plus. This is just not the accurate number. It's just a bucket, bin. When they added this one particular feature, the accuracy went to 90%. Can anyone say what is the reason? What could have been? Is it every time adding a new feature will increase your accuracy? Or is there any science behind this? Or is there any domain behind this? Domain knowledge. If you have watched Titanic movie, you can see Titanic ship is a 3-layered ship, right? Yeah. Women and children saved first. So the 3-layered ship, when the water started entering from the bottom people started running to the second floor. Then from water started filling second floor, again they went to the top. Now, majority of people went to the top, but the lifeboats were very much limited. So poor men took a decision that like, okay, if you're a female and carrying a kid, let's give the lifeboats first. So you can consider that if you are a female passenger with a kid in the second or first floor, chances of having survival is 90 to 95%. At same time, if you're a man, chances of survival is very less. Now, just because we know the Titanic incident, how the decisions were taken was helpful for us to add a new feature called kids. This is the purpose of domain knowledge in any field, any data-driven decision making point of view. If you have domain knowledge, you are having the Swiss knife with you. That means you can solve the problem much easier than you with a bare analytical knowledge can solve. Now, this point, we are trying to predict a column called survived. With the other columns, we are trying to predict one column. We call this as supervised learning. That means when we know what is the final variable we are trying to predict, that is supervised learning. Now, I remove the column from that. Now we have list of data, the same data, but now I don't have the headers here. But I somehow wanted to draw some conclusion from that. There are a set of models which can help you to find the patterns among each of the passenger. They are called different. They are not supervised, they are unsupervised. That means we don't know what to predict, but we are trying to identify some pattern out of it. This is an unsupervised learning problem. Now, when I'm talking about unsupervised, supervised, most of the time we focus on predicting something or predicting a cluster, predicting a class, predicting a number, like that we used to think. What we need to know is, like, if you don't understand the underlying concept about all these models, we won't be able to take any decisions strongly. This is one core problem in modern day. Let me mute down. Okay. So to take it a little more clear, I want to introduce Tom, who wants to play. Consider Tom as a small boy who wanted to play. But Mama says, Tom, outside it's rainy. See, it's very cold, wind is very high, so don't go to play today. Now, Tom's ultimate aim is to go to play today. But the decision-making person is Mama. She's telling it's outside, it's rainy, temperature is very cold, wind is very high, so don't go to play. This has the concept of machine learning and predictions. Now let's see, when you put this particular statement to Tom, immediately Tom will ask a lot of questions. What is climate? What is windy? What is time? And what is temperature? Because these are the things he needs to know in order to take a decision whether he should go to play or not. So for that, climate means all the types of climate, wind means what is the pattern of wind, where I can see temperature, etc. After knowing all these things only, he can go and play. So to make Tom to play, he needs to know all these things. So these are all called independent variables. This is the dependent variable. In simple terms, in machine learning terms, if we say these are the features, and the final outcome which we are trying to get is the target. Let's see how Tom learns. Consider Tom's brain is having a simple table. Day one comes, he's coming to mother and asking, can I go and play? So mother sees the temperature, climate, sunny day, temperature is 40, windy, and it's 8 a.m. Go and play. Second day comes, no, don't go and play because it's a rainy day, temperature is less, etc. Sunny day, third day he's coming and asking, yes, go and play. Fourth day, go and play. Fifth day, go and play. Sixth day, no, rainy day, temperature is very cold and it's late also. Seventh day comes, no, don't go and play. Now, eighth day comes, suddenly Tom is finding mother is not there in home. Now he needs to take a decision. If he needs to take a decision, he should take a decision which will not backfire him. Now, if we take a wrong decision, ultimately he is going to get enough from his mother. So how can we help Tom to take a decision? Tom thinks that, okay, today what is the climate? Rainy day, temperature is like this, wind is like this, it's this time. Absolutely no, because he will compare with the last few days, how was the pattern, and based out on that, he'll pick that decision that no, I'll not go to play because it's a rainy day. Generally, if the temperatures are low, when the wind is light and it's late evening, mother will never allow to play. So this is how anyone learns. Now, when you see a classification problem or a regression problem, we have different metrics to believe. Now, for example, if I say I predict something tomorrow, it's going to rain, first and foremost question everyone will ask me is, how sure you are? How can I believe you? Right? That's quite natural. Every human asks the same question. So in every single model, we have different metrics to measure the prediction accuracy. If these metrics are close to the perfect, that means most of our decisions are correct. Now let's go a little further. I'm taking the same data. I'm having around 15, 16, 17 days of data where 8 days mother allowed him to play, and around another 8 or 9 days mother doesn't allow him to go and play. Now from this 17 days, I am taking 70% of data as a training and 30% as testing. Now here, when I'm taking training, I am taking pretty good amount of data, which is mix of yes or no. But when I'm taking for testing, majority is no. Now, whenever if I build a model, most of the time it will be biased towards yes or no. So what I can do, because it's like teaching a kid all these different types of syllabus, but my questions are only focused on one type of answer, there is a chance that kid may be not able to take a decision properly. Now what we do, we shuffle them in such a way that everything is arranged in an evenly pattern. Now if I take the 70% of data and train a model to learn that how to differentiate whether should I allow him to play or not play, then the next 30% data, I hide it, the answers, and give that as an input. This input is giving me an output called prediction. Now I already have the actual data which is hidden. I'll compare that. So now actual data correctly predicted, second correctly predicted, third is correctly predicted, fourth is wrong, fifth is correctly predicted, sixth is correctly predicted. Now my model is 95% accurate. So we should understand data is the core. If your data is really good in quality, you can believe your predictions. If your data is poor in your quality, believing your predictions will be very tough. Now, what you should understand is it's not the big amount of data, the size of data doesn't matter. It's all about the quality of data and how much it can help you to draw a decision boundary. That is very important in any decision-making process. So let's see in modern day, what is the biggest problem, common approach which people, I can see majority of you all will be doing the similar thing. And that is why most of time ambiguity will be your most, threatening friend. Okay. In today, what happens is when you see high dimensions of data, which are coming from different data warehouses, etc., are being pumped into the organizational data pipeline. Now, what you do, you are having the BI dashboards, like different tools like even Python, Chartio, ClickView, Looker, everything are there. This big size of data you're trying to visualize using a BI dashboard. Now, you start exploring that. Your exploration also is having more number of outcomes. Now, what happens is your results are ambiguous. Here, the funnel is not becoming sharper. The funnel is becoming even narrow. So what happens is the result which has to be narrow is having more number of outcome. This is happening in modern day. Majority of organizations today have what they do is, as there is no data-driven decision making like training being applied into it, this huge amount of data, they directly start exploring. Finally, they will get a huge number of insights and it will end up in ambiguous dump reports. Majority of data analytics process fail due to the tools they use. It's not because of the tools they use, it's because of lack of training. What is the right approach then? How to take a right approach? Let's see this. When you have high dimensions of data, use any AI-based identification. Here, I have put PredictPC. That is something which we have built. You can take any AI-based tools which can help you to identify the most important factors in that data. And that particular data, you can explore it using any visualization tool. Then you bring it into the final outcome where you can understand the funnel has becoming more narrow. Again, AI is helping you to narrow down the features. Next thing is identify the impact of each features, which gives you a straightforward answer. That is what is really contributing for the outcome. This is called the right approach, called data-driven decision approach. Is everyone clear with it? I'm just taking a pause. Is everyone clear about it? Great. Now, going forward, the approach of right DDDD, domain-based data-driven decisions. First thing is you should map organization's vision, what the organization really wants from the data. Second thing is obtain leadership commitments. Then see, once you form the organization's vision, what they want from this data science team, next thing is you have to obtain a commitment from the leadership team, because most of the time the CXO level, VP level people appreciate you for your data process, but the mid-level people will always feel it's you're an external threat. So get a leadership commitment. Third thing is gauge the current state. Fourth one is evolve future state requirements. Fifth, conduct DDD training. That is like data-driven decision making that even you can run across your own organization. Sixth one is gap analysis. Understand the gaps where you can fill the processes with data-driven decision making. Seventh one is make implementable roadmaps. Eighth one, establish data governance structure. Ninth one, rapid prototyping with outcome and output-based approach. 10th one, uplift continuous process improvement. This data-driven decision making is a continuous evolving process. You keep fine-tuning it in a systematic way frequently. Now, coming to the main point, learn to love the data, because you should understand if your data is really good, your outcomes are good. If your data is garbage, garbage in, garbage out. Okay. I can see there is one question by Ankit. What is identification? See, identification is nothing but you will be having a lot of data collected in your data warehouses. Most of the time, when you define what type of analysis you wanted to conduct or what type of insights you want to gather. You don't need every single data points. You need specific data points. For that, you can do different levels of identification, which I'll be showing in the shortly in the next last piece of my talk. Okay, there I will tell you how to identify the key data points and start focusing and building interesting use case about that. So here, learn to love the data because data is the key. Now let's take Richard. Okay, consider Richard is the CEO of SimplyBuy. It's like, keep it like it's not a real company. SimplyBuy is like a visual. I'm just for explanatory, I'm using this. In order to build a reliable business, he has few requirements to the data science team to make better decision. So typically in a day of how Richard's day, let's see. He is coming to the data team and say, can I know which product sells together? Consider SimplyBuy is like a allies like Amazon. Then he's asking, can anyone help our HR team to shortlist resumes faster and save time? Third thing, what are the customer feedbacks about our product across geographies? Now, 3 different business questions which Richard has in a typical one day to the data science team. Now, the data science team take all the 3 business problem and they convert them into a data problem. That is from where data comes. For the first one, data can be retrieved from the SimplyBuy inventory. Second one, candidate applications can be retrieved from the job portals. Third thing is, what are the customer feedbacks about our products? Data can be gathered from hashtags, etc. Now, if you take the first one, similar product recommendation. Take this data, you can see a simple data in that user IDs are there and items they have bought are there. Keep it like that for easy understanding purpose. User 1 bought apple, user 2 bought orange, user 3 bought apple, user 4 bought grapes, user 5 bought milk, user 6 bought apple, user 6 bought grapes. Like that we are having it. Now let's transpose this data into this structure. The column, the first column has all the users and all the new columns are each items. So James bought apple, so 1. James didn't buy orange, James bought pineapple, James bought grapes, James didn't buy milk. Now you can see I have put a frequency table. Who is similar to James? Whose buying pattern is similar to James? Can anyone tell me who has similar buying pattern of James? No one is answering. Nix, okay. And who is similar to Mike? So when we really look into it, it's very interesting. Like whenever they buy multiple times, we can increment that 1 with the +1. Now, when you simply apply a very simple conditional formatting, you can see who has similar buying pattern. This can be applied on a very small set of data in order to understand like who has similar buying pattern. For example, you can see James and Rick has similar choices. Rick may like milk as well. Gracie and Tom has similar choices. She may like grapes as well. Mike and Danny has similar choices. Mike likes apple as well. Mike may like apple as well. So a very simple way we can build a simple recommendation system. A very simple recommendation based on the frequency of their purchase and the item they buy and who has similar pattern, which clusters of people have similar buying pattern. So problem number 1, we can solve using this method. Second thing is, SimplyBuy, consider I already said it's like Amazon. It will be having huge amount of pile of resumes being given. Now, how can I have a very small HR team. How can I use my HR team effectively? Very simple. You can take all the soft copies of the PDF, scrape all the text out of it. For example, every username, the entire resumes are scraped. Remove all the stop words. Then what you do? Stop words like the, is, and, etc. and all. Now start counting the keywords which I am very much interested on. And I'm giving a scorecard for each keywords. Now I get a list of users and their keywords and the score calculated for them. Now that's not enough. I can even get a little more detail from other area like social media, like whether what is the personality, how social media, the pages they like, the kind of forum they follow, the comments they do, like that, you can pull the data. Now, from that thousands or even lakhs of record, you can sort column of your choice and start calling them for an interview. Second problem can be solved like that. Third thing is different types of customer. Now, generally, when you open Amazon, everyone opening Amazon, everyone will not see the same inventory. They all will see different types of inventory based out on what type of segment you belong. That is whether you're a high paying customer or you're a price conscious customers or you're a quality conscious customer. Based out on what is your persona, the inventory has to re-render. Else what will happen is this huge inventory cannot be displayed in mobile easily. You will not buy. You will just bounce back. So how to use taking all the information, like every single user, how much time they click, how much time they respond to an ad, how much time they visit the website, what is the loyalty level, usage level, like that, you calculate it. Then you apply a simple clustering technique and find the important clusters. And if you understand what is binding them as one cluster, that can be the core of that particular cluster. Then you can show for a low price conscious customer, pick that cluster, show only those products. For quality conscious customers, show only those products. So clustering can help you to take decisions based out on your behavior pattern. Next is sentiment. You know that like whenever we buy anything today, we go to social media, first and foremost thing we put it is, I bought an Apple iPhone 6, iPhone 7, like that, we start tweeting. Everywhere we tweet. Now, all the social media has something called hashtags. So if you take one hashtag like hashtag iPhone 11 and pull out all the tweets, it comes. Now, if you apply a very simple sentiment analysis on each tweets and you apply it on a chloropryth map, a CEO of a company can understand, okay, overall there is a neutral sentiment, only PA and CA are having a negative. Maybe it can be a logistic or supply chain issue. You can directly call to that particular stores or that particular head from that locality and ask what's happening. So what happens is data start generating stories, and it start when you ask the right question, it's giving you very interesting outcome. How to find story from the data? How to find is very simple. Now let me take you to a very interesting example here. I was talking about all these things. How many of them use spreadsheets regularly? How many of them use spreadsheets? Google spreadsheets? Okay, great. So I'm just coming to the spreadsheet. Let me share my screen resumes. Let me go and okay. So can everyone see my spreadsheet? I hope everyone can. Okay. Now here I am having different data. For example, very simple for purpose of doing that. What a no-code analytics platform is all about, right? A no-code analytics platform is nothing but how can you analyze data, or how can you run all these different types of use cases without writing single line of code, right? So I'm coming to the Google Sheets. If I go to Google Sheets, there's an extension. I go to the add-on, get add-on. So when I come here, I search for predict EC. This is the add-on which was created by us for anyone to install it and start exploring data or using any kind of AI/ML algorithms in your spreadsheets itself, so that we are not taking data to a tool, but tool inside the place where data lies. So you come to predict EC, I come here, I installed it. You can come and install from the marketplace. Once you install, you give a refresh to this page. Now what happens is, I'm having consider this is like a sentiments. I can bring sentiments through different way. I can scrape the data, etc. Here I'm coming to the extension. I can see an option called predict EC. So I am launching that app. It's purely in the Google Sheets, Google Workspace. It's free. Anyone can just go and install it, and you can create an account. You can create an account here and you verify email, but I'm directly logging inside. Robin, not CleverInsight. Okay. Now, when I log into this particular application, It's completely a Google add-on. What you can see is I can see a lot of things like data preparation tools, statistical tests like t-test, ANOVA, Spearman, etc. Time series forecasting tools like anomaly detection, forecasting, correlations, classification, regression, clustering, sentiment. Now I'm going to the sentiment and I'm selecting the fields which I want to analyze. I select these fields and I select the range. Now the range is get. Now I want the outcome to be in this cell B2. I'm putting B2. Now if I click sentiment, what will happen is ultimately a sentiment analysis is happening. This can be happening for any number of fields. So here there are 17 positive sentiments, 9 negative, totally 26 sentiments were being calculated, and this is a positive sentiment, positive. So here the score is also being calculated. This can be of any size. How much data Google Sheets can accommodate, that much you can do analysis. Here I'm just for a quick insight, I'm just taking 26 record. So number one, I can do a sentiment analysis using the Google Sheet itself. Second thing is I want to do a forecasting. Now I have a timestamp. I've just kept the timestamp in Unix timestamp and the sales, for example, each day there is a sales like that. Now I want to build a forecasting model. So if I go to time series forecasting, it's asking for the data. I'm just selecting the data like this. And I'm selecting the range. Yes. Now I click the forecast. Please select only 2 columns. Okay. I'm just selecting these 2. And I'm just refreshing it. Okay. Now I click the forecast. Okay. Now you can see future dates forecast has been created. Now if I select all the 3 columns and I go to the chart and insert a chart, yeah, I can see this is the known data, this is the forecasted data. So I can run a forecasting without writing a single line of code. Now third thing is, let me go to interesting. Okay, I'm having a data about different ad revenues. For example, I am spending for TV this much like money. For radio advertisement, I'm spending 0. For competitor sales, this much. For this is the revenue. Now I want to cluster what are the, if I go to this clustering point, now I want to cluster these different types of ad and see like which are all belonging to one type. Okay, or I will come to this point. I'm selecting the data from here to down. I'm selecting the range. I want to do a simple clustering. I want to split it into 3 clusters. I'm selecting that. Now I run a clustering. Now when I run a clustering, a new column will be created called cluster, which will be showing that each record belongs to, you can see here now, the first record belongs to 0 cluster. These are all 0 cluster. This is the second cluster, 0 cluster, second cluster, first cluster. I can run a simple clustering model in the same spreadsheet, which can help me to cluster any different types of problem statement in the Google Sheet itself without writing a single line of code. Now, coming to the next important data point, let me go to consider anomaly detection. Consider I have a data where I want to see is there anything anomalous happening. So I go to anomalies. I'm selecting the data points and I'm just selecting the range. And I want the data to be in the C1, C2 field, C2, and I run the anomaly detection. Now, automatically the anomalies are calculated and it's creating a new column. Okay, all this minus ones are all anomalies. There are ones and minus ones. I can little zoom so everyone it will be visible. Yeah, you can see there are 1. This is an anomaly and this is an anomaly. You can run anomalies to detect is there anyone who has an anomalous behavior or anomalous buying pattern, etc. Next, finally, I'll come to the important next. For example, this is your telecom churn, right? Generally, we do the telecom churn prediction. So I'm going to the classification model. I'm telling there is a column called state, area code, international plan, voice, etc. I'm selecting that as the X variable. Okay. And the target which we want to predict is the churn column. Just like coming to this, and I'm selecting this column. The first one is a header. I'll give you 2 cross validation, 2%, take it as test. And now if I click the classification, it generates a report. If I click onto the report, you can see that the report has the model is 86% accurate with recall score of 62%, precision score of 71, F1 score of 0.36. Now, if I come down, I can see sharply the explainable point of it. That means people who spend more like a day's total day minutes are having high chances of what to say, they're getting churned out. And international plan, if they are not, if they are having international plan, they are not churning out. If they don't have international plan, there is high chance that they churn out. And if you go to the next thing, ROC, you can see the ROC is around 0.87%, and which shows that precision recall, how much the precision recall point is. Then what is the confusion matrix? You can see the different true positives and false positives. Then feature ranks, what really contributes for a person. International plan, if someone is having, is a main feature which shows whether a person will churn out or churn in. Area code, second, total day minutes he speak, days, which days, etc. So Ankit was asking what is identification. Here I can identify the top 4 features which are responsible for a person churning out of my one network to another. If I go to the pairwise grid, I can see even better idea about if a person is having total day. Here you can see the red and the yellow means, sorry, the orange means is yes, someone who's churned out. No means it is green. So people who generally churn out are having a total day call between this range. Day call and day minutes are in this range. And here you can see a person who does not churn in are having a higher rate here. A person who doesn't speak much, like who doesn't use day minutes regularly. You can have any number of calls, but how long you speak in each call really makes a bigger sense. So this can help you to check with, and also you can see multiple models. 2 models are automatically built with it. And I can compare the models also. That totally 2 models, which I gave the CV score as 2. So 2 different models. If I give 5 different types of models are built. Now there is an interesting thing that's called simulator. Here I can come and see if a person who is coming from TN state. Okay. Now his chances of probability of him churning out is 95%. He doesn't churn out. But if a person is having international plan, again 75%. About this area code, if I change, and day minutes I'm increasing. If I'm increasing day minutes more, you can see the percentage changes. And this is an explanation for each prediction. That means for every single prediction, it shows that in this prediction, area code has given plus, a positive impact on 1.81 percentage for this particular prediction, and state at which has given minus 0.81, total day minutes. So this is a local interpretation about it. So you can go and play around with it. Each model, you can shift the model also to model 1 to model 2. And you can see the inferences from this, whether a person will churn out or churn in. So what we have to see in this overall pointers, we are able to move from the realm of making decisions without writing a single line of code. So coming here, how to find stories from data. First, most important thing is, whenever you have the data, you plot it, see that your data is having a trend. If there is no trend in the data, see if there is a data is having at least a pattern. If there is no pattern in the data, check whether there is any outlier. Most of the time, there's outliers. If it is not caused due to data error, that will tell an interesting story. So first, understand the abstraction. That means explore the data to find the pattern, trends, or outlier that can form the basis of a story. Second thing is choose how to tell it. That's a representation. Using the right axis can really help your story to get more detail. Third thing, use aesthetics, make it compelling. Use proximity, alignment, repetition, scale, contrast, hue, saturation, and subtraction can all be used to emphasize your findings. So here I'm showing a trend without any distraction. Pattern, I'm differentiating with two different contrast colors. An outlier, I'm only picking the outlier and showing it as contrast, and rest all the things which are not in interest are kept in low light. Next, messaging, narrate the story. When you narrate the story, like in this one, I'm putting a red line and telling that's the goal was exceeded. Here I'm telling two groups were identified. This is an unusual finding. So adding the right narratives to the story gives more interesting view about your insight. So use visualization to enhance your message. Find your story through exploratory visualization. Choose a suitable representation for your story. Use aesthetics to highlight your finding. Support with appropriate messaging. These three are here. First I'm exploring, next time representing, next I'm adding aesthetics, then finally I'm narrating. So with this, I'm coming to the end of the session. Code is not an asset, it's a liability. With this, I'm coming to the end. Now I'm open for your questions. So if you have any, I can see a few questions, sir. Please provide the link for it. Sonam, which link you want? Hello. Vinay, at this moment, the clustering algorithm is a k-mean clustering, which is running behind that. You can use even other clustering, hierarchical clustering, etc. And Parul is asking, can we use this add-on in Excel as well? Yes, Parul, very shortly we are going to release the Excel add-on as well. So we'll just keep you posted. Any questions? Okay, predict easy. That you can directly go to Google Workspace and like in add-ons, like if you go to Google Sheets, there is an extension menu, get add-on and type predict easy, you should be able to get it.
Hello,
Any questions?
Bastin sir.
Yes, madam.
I want to know if someone is not really interested in coding, but is interested in data science. So is there a possibility?
High possibilities mainly for them. I can see most of the people who are coming from non-technical background are really good data scientists.
Okay. Thank you.
Yeah. Yes, I can provide. I will provide it to what to say. I'll provide to the coordinators. You can get. They will mail you. Okay, I'm working with government. Sometimes confidential data is to be sealed. Is to be sealed and is added on secure for it. I didn't get your question properly. Okay, you mean the add-on. Fine. I won't recommend you if you have any requirement to handle confidential data into it, you can reach to me. Here is my email ID. Definitely. I won't suggest you to upload a confidential data, but most of time marketing and all other different types of data. And if you are having a Google add-on in your own organization, most of the time it will be having its own isolation. But very confidential data, it's better to run an intranet version of PredictEasy, which we have it as a separate service. Yeah. Any questions? Feel free to ask your question. You can unmute and ask the question.
Hello, Bastin sir. Nupur here again.
Yes, madam.
Sir, but Python is must. I have heard this in advertisement of data science.
What, madam?
Python is must, they say in
that is for data engineers, madam, mainly.
Okay.
Most of the time, the data which a decision maker really gets is a subset which is being done by data engineers. A data engineer does not need to sit and build the models and all this thing. They will be helping you to get the right set of data. But most of the actionable data are subset of data which are filtered which doesn't need any programming language.
Okay, okay.
If you are
Thank you, sir.
okay, there I can see Silver Spray, like which programming language should I focus on? If you really wanted to learn a programming language, I would say Python is a good starting point, because if data science is your area forte, Python can really help you much more easier way. Or if you are a person who are more analytical driven, you don't want to build models and deploy, you can go for R.
Okay, thank you, sir.
Yes, ma'am. Any opening?
It's a Ketan here, sir. So my question was to break into the field of data science. What are the kind of projects you would recommend to freshers and people who decide out of college?
Okay. See, in data science, if you really ask me what really made me excited towards this, if you take any toy data set, okay, generally what happens is people take this toy data sets and start working onto it, and they'll start gaining insight. That is in an entry level, that's fine. But if you really wanted to see data science from a bigger perspective, pick a domain which you are really excited at. I'm very much excited on counterterrorism. So every time when I start looking into the data, I have the thirst of finding that data from different sources. That interest one fine day made me more data centric person, rather than like I went to some big universities and learned and came, which gave me lot of insight about what is the purpose of each algorithm, when to use which algorithm, when to not use AI as AI ML. Most of the time people think that AI ML is the final thing in data science, but it's exactly like telling the only weapon which you have in your hand is a hammer. Everything will look like a nail. So it's having a combination of multiple things like operational research, data analytics, data visualization, data narratives, data engineering, data pipeline, etc. So I would suggest you pick the projects which you can formulate. I mean, like something which is exciting, where you get access to the data. Number one thing is, if you don't get access to the data, every time you will be end up in a point of only collection itself. But you should see a data set which can really excite you, and you should be able to come with the confidence that, okay, by end of this things, I will find the most important aspect from the data set, and I will derive it into a very good story. And that detailing of work is something which I would recommend more. It can be any small data set, any small assignment, but how much clarity you put into it is the most important thing. And focus mainly on the techniques rather than tools.
Thank you, sir.
Yeah. Ravi Bhushan, any opening is absolutely, you can reach to CleverInsight website and apply. There are openings definitely. Sir, I'm about to complete this diploma and I've been applying for jobs, internship, but I'm not able to get short anyway. Can you please suggest what other skill set I'm looking for? Because, okay, generally what we look is, we don't ask whether you're from which institution, everything and all. We first focus, we give one data set which looks completely anonymous, and we give it to them and say, like, can you analyze and come? Most of the time students comes with insights of which model should I use. My first important response is like, did I ask you to build a model? So I would say, like, you build use cases which really are, it can be small, but it should be very powerful insights out of it. If you bring very powerful insight and the step-by-step approach which you took and the hypothesis behind why you took that decision, it can be anything, but you should be very confident on supporting. You should have the supporting document. It's exactly like a lawyer going into the court and who is fighting your case with all the facts other than just all the junks. If you go to ChatGPT, one good thing is if you ask one question, it will give you a very beautiful answer. 90%, 99% of people will in the first attempt will get impressed. But if you read that answer 10 times, you will understand that model is hallucinating. It's talking a lot of good things, but the facts are not there. So I would say, like, Parul, it is important. You should have a clarity on what projects you worked out on. It should have a very clear approach of how you started with exploring, seeing the data quality, what and all steps you took to clean it up, and what steps you do to analyze and like focused on exploring the data, and what projections you have built, And out of this, what is the conclusion? What conclusion you're giving? When most of the time you keep it in mind, a company is appointing you as a data scientist not to come and tell tomorrow the rain will come or not. That anyone can tell, any model can tell. I want you to specifically strategize and say, hey, if I am going to increase the revenue cost of this particular product, I may be able to sell this product higher because this is my target. And this much percentage difference it will come. That is what actionable insights. So focus on actionable insights, and that will definitely give you a job. How can I master the prompt engineering in order to gain more of AI? First, understand before going to prompt engineering, just to see what are its possibilities. And first, more than anything else, understand its limitations. If you understand limitation, like ChatGPT can do a lot of things, but regularly you need to ask different types of questions. You will understand that certain questions, if you ask right way, you will get answer. But if you slightly have a different context, it will totally mislead you. So I would say mastering prompt, there are a lot of prompt guidelines being provided by specific AI tools. For example, ChatGPT has its own structure, templates given. Go through it and start practicing.
Sir, Sonam here.
Yes, Sonam.
Sir, my question is, in these days, for the freshers especially, organization fixed some prerequisite like Python or any other coding language to become a data scientist. So how
Okay.
can a non-technical person work as data scientist or data analyst?
Okay, I would suggest there were like 2 interns in our own organization who come absolutely with zero Python knowledge.
Sir,
But
it
you
is a
won't
rare case, sir.
no, I'm telling. The thing which impressed us was their ability to build a story around with the bare minimum tool like a spreadsheet, and how much clarity and the type of problem they solve really get impressed. And the depth at which, see, this is a depth first approach, not a breadth first approach. How much depth
Yes,
you can go into one and use minimal tool to bring maximum insight, we will understand learning a language is easy for them.
yes, yes, but it is difficult, sir.
It is, but that's why I'm telling you, rather than mainly focusing only on the machine learning and the AI part, focus on what really data can give for an organization, how data science can increase the ROI of a company. Not fancy projects will impress them. The thing which impresses, how can that company's ROI can get impacted if you approach this problem with this particular problem statement,
Yes, yes.
right? Can you also suggest some resources, YouTube channels? I would say one very good, to be frank, there is a guy called David Langer. His YouTube channels are very good, and he speaks mainly on spreadsheets. And it is one of the great YouTube channel which you can follow. So I think we have come to the end of the session. So
hello, sir. Am I audible?
Yes.
Sir, I'm doing a project on data analytics mainly.
Okay.
I only uploaded my data. It was a huge data containing nearly about 90,000 data points.
Okay.
And I uploaded that to S3 bucket.
Okay.
And I'm trying to do fully automated from EDA part to visualization using Power BI, fully automated sim.
Okay.
So it is a very good, seems to be a very good project because
Okay.
it contains all the data analytics parts like SQL part, then EDA part, and
Okay.
trying to take, it's a retail data, and it is, I'm trying to get retail insights from that data using
Okay.
S3 bucket, and it's a very good project. Is it a good thing to do that?
Absolutely. Absolutely, that is a good thing.
Actually, this was being advised by some person to do such.
It is absolutely.
He straight away told me, you don't get inside to ML and AI and deep learning. That will take huge time.
Correct.
In industry, you will first try to understand data. What data wants to say.
Correct. That is important. Most of the time we fall into the trap of AI ML directly without knowing that most of problems are not AI ML problem.
And
even
it,
that has happened.
that like you sent me, you talked about that Titanic data set. He send me a fully one that analytical path, and it was containing a huge insight like what age, why. He told me to go and watch that movie first.
Yeah.
He requested me watch. If you
Correct.
haven't watched, watch that. And
So
now
that
then he told me to see, explain with the help of these data.
Correct.
Then why, how like females were surviving more, first class ladies were surviving, all men died, which age group was saved, while child were given priority. That movie was truth, but from that data and doing analysis, I came to know that these are the reasons why the movie has been made. And
yes,
from that insights,
that's why I say like the depth is more important on
I
what
never
explain.
thought that data can speak so much.
Yeah. Good one, Ravi. It would be great if you sometimes spend some time on the same use case with your other colleagues who are working. It will add more. And also remember, data science is a group activity, not a single person activity.
Yes, definitely.
So I think we have come to the end of the session. Thanks for being very patient enough. And if you have any queries, just reach to us. I will be sharing these PPTs, whatever I did to the like IIM Madras coordinators. They'll be sharing it to you. So, Jayashree madam, can we wind up?
Thank you, sir. It is a very good session.
Thank you.
Thank you, sir.
Thank you.